All right, hello, this class. This is Mr. G. Today we are going to talk about Rock Transformations, Chapter 3. How do rocks get from one place to another? We've learned about the Rocky Mountains and we've learned about the Great Plains. The Rocky Mountains are mostly igneous rocks formed by cooled magma, and the Great Plains are mainly sedimentary rocks formed when sediments compact and cement together. But how did they get there? If rock that was cooled under How can rock that is cooled underground, hot magma, move up to where it can be weathered? How were the Rocky Mountains formed? And how can sedimentary rock move down to where it can be melted? The sedimentary rock of the Great Plains. Chapter 3. How can rock from one of the regions have transformed into a different type of rock in the other region? Well, we know that energy can come from two places. First, it can come from the sun, and it can come from the core of the earth. Energy from the sun can weather and erode down rocks, and energy from the core of the earth causes plate tectonic movement. We've learned about plate tectonics um, and how the plate tectonics are moving because the mantle, the hot liquid or hot soft solid rock, is moving underneath the crust. So you can see all of these rock formations are moving away from each other. And all of these rock formations are changing too over millions and billions of years. The key concept: when plate motion moves rock formations. When they move and are exposed to different energy sources, they can transform. When rocks move and are exposed to different energy sources, they can transform. Now we're going to learn about subduction and uplift. Subduction, the process by which rock formations move under Earth's outer layer and into the mantle due to plate motion. Uplift, the process by which all the rock formations of a region are pushed up due to plate motion. So here we have a diagram, a model of what we're learning about. You can see that at a convergent plate boundary, this plate tectonic is subducting under the other plate tectonics. It is going underneath it. This plate, because of all this rock moving underneath it is being uplifted. All of this rock is being pushed up toward the surface. Subduction moves rock down below Earth's outer layer. It can bring sedimentary rock, compacted and cemented sediments, down to the mantle to be melted. Uplift moves rocks upward toward Earth's surface. It can bring igneous rocks, cooled magma, up to the surface. Now we're going to discover a new rock. I have my rock. He is at the surface of the Earth. During subduction, along with all the other rock formations, my rock will move down underneath toward the center of the Earth, underneath all of these other rock formations. But as you can imagine, moving down into this place, being surrounded by rock on either side, my rock is going to feel a lot of heat and a lot of pressure. It's being crushed from two different sides. So all this heat and pressure is going to change the rock into a new form of rock. This is called metamorphic rock. Metamorphic rock is the type of rock formed when heat or pressure deep underground changes existing rock. The same can be observed for uplift. If I have a rock formed at the mantle, and due to uplift, it is raised up, it will feel pressure from both sides. It will feel pressure from the top, from all the rocks crushing it, and from the bottom, all the rocks below it. And during uplift, it will keep being raised up to the surface until there's pressure from both sides. This, as you can imagine, will change the rock into a different type. Heat and pressure, once again, have changed the rock into a new type. Remember, metamorphic rock is the rock type formed when heat or pressure deep underground changes existing rock. The rock cycle. We have three main types of rocks: igneous rocks, sedimentary rocks, and metamorphic rocks. Rocks can transform and change between each type due to energy from the sun, energy from the core of the earth, and plate tectonic movement. Igneous rocks can become sedimentary rocks can become metamorphic rocks can become igneous rocks. Igneous rocks could become metamorphic rocks could become sedimentary rocks, and sedimentary rocks could be igneous rocks. First, let's look at the first step of the rock cycle. Energy from the core of the earth heats up and melts down rock. This creates magma, super hot magma. When the magma cools, igneous rock is formed. Uplift brings rock up toward the surface. Heat and pressure may change some of the rock into metamorphic rock. So at the top, we'll have igneous rock and metamorphic rock. Energy from the core of the earth heats up and melts rock. When magma cools, igneous rocks is formed. Uplift brings the rocks to the surface. Heat and pressure, in the middle here, forms metamorphic rock. Energy from the sun the second part of the rock cycle is this. Energy from the sun creates weather patterns. Wind and rain weather and erode down rock. They are broken into sediments which fall downhill. Compaction and cementation create sedimentary rock. So when wind and rain break down metamorphic rock and igneous rock, they can become sedimentary rock. The last part of the rock cycle. Energy from the core of the earth moves plate tectonics. Subduction can bring all plate types underground. As they move underground, some of the rocks can experience heat and pressure to form metamorphic rocks. And some rocks are brought all the way down to the mantle and melt again. Some of them can be exposed to a lot of heat and pressure and become metamorphic rocks, and some of them will be brought all the way down to the mantle and melt again. That is the rock cycle. Remember, we have three main types of rock: metamorphic rocks, which are formed from heat and pressure; igneous rocks, which are formed from cooling magma; and sedimentary rocks, which are formed from compaction and cementation of sediments. Rocks can transform and change between each type. Great job.